Hello and welcome back to my channel. So today we are going to do another hacker rank in the 1 month prep kit, and it's some really complicated way of explaining a simple problem. So they're given a story which is the birthday bar. So basically they're two children, Lily and Ron, and they want to share a chocolate bar, and each of the square has an integer on it. So yeah, okay. So Lily decides to share a contiguous segment of the bar selected such that who does this? But yeah, anyways, I'll just visualize as I'm reading the question. So she decides to share a continuous segment of the bar. That means like it if I selected two, I shouldn't be like one here and one here. I shouldn't do this. It should be a it should be adjacent, and there shouldn't be, yeah, basically it should be adjacent. The two bars that if she decides to give two bars, the two bars must be adjacent to each other. Anyways, so what she's saying is the length of the segments must match Ron's birth month. So if he's born in Feb, that is 2. The length of the segment must be 2. And the sum of the integers on the square must be equal to the birthday. So in this case, D is 4, the day is 4. So if it's 4th Feb, that is 04, 02, some year, some random year. So yeah, since it's 04, the sum of the two segments must be equal to 4. In this case, which is just 2 and 2 and 1 and 3. 3 and 2 don't form that, and we cannot get this 2 to come over here and do something. So in essence, all we can do is just find these two sets, and if I'm not wrong, it returns the number of ways the bar can be separated. So in this question, the answer would be 2 if I'm not wrong. Am I wrong? Let me just check. The line contained by complete the birthday function below. Birthday is this thing returns the number of ways the bar can be divided. So yeah, the two segments meeting a criteria, the two segments. So if I'm not wrong, the answer should be 2. The returning answer should be 2. Normally in hacker ranks, they'll be a bit more clear about it, like how the returning value would be. I guess this is clear enough. But yeah, something feels odd about this question. Okay, so it's not a very out of the world kind of question. So let's just get straight to coding it. Before that, I just want to print out everything because there are multiple things over here. I just want to see what I'm working with. So print them out, and HackerRank is lagging. Oh boy, it's lagging really a lot. Okay, so what we're getting is we're getting the array of chocolate bars, like the bars sequence, and then we're getting the day and the month. So remember again, the sum of the segments must be equal to the day, which is D, and the length of the sequence is supposed to coincide with M. So, okay, cool. This is what I'm going to do now. Basically, first thing I'm going to do is I'm going to first sum the first M number of things. So what am I trying to do is, let's say I have an array. Let's say it's size, this size, this is 5, and M is 2. That means the segments must be 2. So what I'm first doing is I'm finding the sum of the first two indexes, and then I'm just going to shift it by 1, shift it by 1 more, and shift it by 1 more. That way I don't, like, over here 2 is a simple number to calculate, but what if it's like many numbers? I don't want to, like, a sum operation runs on a n time complexity. That means if there are 5 numbers, it will run 5 times. So we don't want that to keep summing every single time. So what I can do is I can just find a way to sum it once and then keep track of the first and the next item, and then just keep adding that to see the next one. This is a really powerful way of shaving off some time complexity from the final solution. Okay, if it doesn't make sense now, I will code it out. Just Python is quite interpretable. It will look like pseudocode. So yeah, you can just read that. So what I'm going to do now is, first thing, I'm summing the so the first M letters. So sum S all the way to M. So this will be the first M numbers. I'm summing them. So for I in range, let's see. What should I put? M all the way to len S. What's wrong? Oh, it should be a comma, not a colon. Okay. So I have the sum of the first element. I mean the first section. So now what I need to do is I need to keep track of the first one and the next one. So I will start from M all the way to len S, which would be 1 minus length of S. So it'll be here. So what I'm doing, what I have over here is I have something that goes from here all the way to here. So okay, I think a better way to do this is let's just create pointer values. So pointer 1 is 0, while pointer 2 is equal to M. So now what we are going to do is we're going to find, we know the sum of the first one. All I'm going to do is if so we first need to run the first item, like we first need to check if this satisfies the condition of it being equal to that day's worth. So let's try if sum is lesser than, no, if sum is equal to day, we need to create another item to just keep count of all the successful items. So count is equal to 0. If sum is equal to D, count plus equals to 1. And M minus 1, because I want to start from the previous one. So I'll be starting from here. Because I need to, like if I do from M to length S, I'll only run this 3 times, 1, 2, 3. But if I do M minus 1, I'm starting from here, it'll be 1, 2, 3, 4. And there are 4 comparisons to be made. So I want to do all the comparisons in one go. So I'll be doing this. So M minus 1, count if the sum is equal to D, I'll be counting plus 1. So how do I get the sum? Okay, let's do it. Let's retract a bit. If sum is equal to D, I'm adding 1 to the count. And there's no else condition, else it'll just continue. But either ways, if it is equal or not equal, I need to move on. I need to progress to the next level. So sum is going to be equal to, okay, let's say plus equals to S pointer 2. I'm going to be adding pointer 2. That means right now it is all the way up until 2. So if it is M is equal to 2, 0, 1, 2, I'm going to be summing everything up until 2. So 0 and 1 will be added. So the next step would be adding the 2 and subtracting this index 0. So I'm adding 2. Pointer 2 is currently M. I'm adding M. And then I am deducting the first element, which is pointer 1. Pointer 1. Oops, sorry. Yep. Once I'm done modifying sum, I can modify the pointers afterwards. So let's do modify the pointers. Both pointer and pointer 2 are going to experience a +1. I don't know if this is synthetically possible. Okay, I guess not. Like, why risk it, right? So plus equals to 1. Wait, let me just try. I'm quite curious. Does this work? And no, it doesn't work. Okay, why am I being greedy? It doesn't help me in time complexity wise. It doesn't help me in any ways. It's just because one line I'm trying to fix it. Anyways, now that I've modified the sum value to the next item, I can just modify the pointers to point to the next condition, and then I can go back into the loop, and I can keep going all the way until I compare all 4 of them. If the sum at a certain point is equal to D, it is going to count. It is going to add to the number of combinations that are successful, because that's the last thing that we need to return, right? The number of ways that the bar can be divided. So now all we need to do is, after it has run through the for loop, I can return count. So let's run the code. Hopefully it's all working fine. Whoops, what did I miss? Index is out of range. Okay, the issue now right now is, sure, it works all the way up until here. Once it reaches here, once I've compared this, I'm summing something else over here, which is I'm trying to find pointer 2, which is now referencing the last, like there are 5 index ways, 0, 1, 2, 3, 4. I'm trying to reference 5, but 5 does not exist. And even though I don't care about this, like even though I like once I reached it, I don't care about this, it is still going to do this because it is part of the for loop, and hence it will return an error and I will be in deep trouble. So to counter this, what I can do is I can make sure I don't expect, I can just make sure that if pointer 2 is lesser than m, not m, sorry, lesser than len s. Yep. If pointer 2 is lesser than s, then I allow it to modify. Otherwise, I'm going to ignore it and I'm going to go to the next item, which if it is the last item, it'll just go to return. So let's try running this now. Come on. Come on. Yep. So it works. So what this is a kind of a lazy way of handling the error that I'm getting over here, but this is the only right, like it. Okay, I shouldn't have said lazy way. I saw the problem and I fixed it by identifying the problem, giving it a correct solution. So yeah, there might be a better way to do this, but this is a very efficient program because it's going to run at an n time complexity, less than n actually. And because I'm summing it only once, so I've been through these two, then I'm just subsequently continuing with the rest of the items. So it is literally just n time complexity. It's highly efficient and it doesn't require like multiple lines. So on first glance, someone might be just interested to just sum these arrays at every single point of time, but sum, as I mentioned earlier, would be m time complexity each time. So if there are 4 segments over here and it has to do it m times, it is m times d time. It is, if I'm not wrong, if I'm doing my math right, it is m times, m is the length of this, times length of s minus m plus 1. 5 minus 2 plus 1. So this is the time complexity that we're looking at, which is Sm minus m square plus 1, which is just m square, and it's not time complex. It's very computationally intensive, and we don't want that. That's why we don't recommend this. Over here, we just sum it once. It goes at a this works at an m time complexity, and this works at a s minus m time complexity, and in total is just s time complexity, effectively O(n) time complexity. So yeah, it is highly efficient, and I recommend you guys considering this trick for your subsequent array traversal kind of questions. So yeah, hope you guys enjoyed the video. Wait, I didn't even finish the video. Yeah, it passes all the test cases because it's very efficient. In the event, it's slightly bigger. Like if it has many things inside, it will fail some test cases, and that is not good for you. So yeah, hope you guys enjoyed the video, and I will see you guys in the next one. And with that, I think we are done with the first week in the 1 month prep kit. And yeah, it is. I did spend more than 1 week trying to do this video series. Next week, I think the next week series, which would be slightly harder if I'm not wrong, it will be preparing us to be more proficient. And I'm looking forward to seeing harder challenges. I'm expecting something like a linked list kind of stuff. Those are a bit more intermediate in terms of difficulty. And yeah, hope we get to see more interesting, funny stories like this, like Lily and Ron trying to split a chocolate by using Python. Yeah. So I'll see you guys in the next video, and peace out. Bye. Stay safe.